Now let us have a quick look on the conventional electric drive which was used in the olden days in the industries. Now let us assume I have a load which requires a variable speed operation. For this I require some system something like what I have shown in the figure. I have an AC motor which is coupled with a DC generator, and the armature of a DC generator and the armature of a DC motor are linked, and the DC motor is coupled to the load which has to be controlled. Now the AC motor is being excited with the fixed supply, so the speed of a AC motor will be also fixed. So since the AC motor is coupled with a DC generator, the DC generator also rotates at the fixed speed. Normally the DC generator used is an separately excited DC generator. So if I try to vary the field current of a DC generator, the armature voltage which is generated from the DC generator also varies. So the DC motor is coupled to a DC generator which gets a variable DC supply from the DC generator, since by varying the field current of the DC generator. So once the armature of a DC motor is getting a variable DC supply, the speed of the motor can also be varied, since the speed of the motor is directly proportional to the armature voltage. This was the system which is used to control the loads which was used in the olden industries. But this system has lot of disadvantages. Let us see. It is bulky in size. Say for example, to control a particular motor I require 3 other machines. So the system generally becomes so bulky. It is high expensive. To control one load I require 3 machines, which is so costly when compared with other type of control methods. It is inefficient because 3 machines, generally rotating machines, have an efficiency from 80 to 85 to 90. So automatically the overall efficiency of the system also reduces. It is so complex. In order to control one load I have to control 3 machines. So this was a system which is known as a ward linear system, which was introduced in the years of 1890s. So because of the problems associated with the ward linear system, we have to switch on to some other sort of a drive system which eliminates all these disadvantages. This becomes possible in the years of 1960s after the invention of power electronic devices. Now let us see the block diagram of the modern electric drive. The modern electric drive consists of a power processing unit, which is in general a power electronic system which is used to control the motor. The motor is being coupled with the load, and it has a control circuitry also. The control circuitry generates the firing pulses required for the power electronic system, which is in the power processing unit, and the feedback from the motor is being taken in order to produce the firing pulses according to the requirement. So this is the general block diagram of a modern electric drives. The main advantages of this modern electric drives when compared with the conventional electric drive is it is very small and very compact, highly flexible, it is very efficient, and it is also interdisciplinary. So generally I require a control reference which is being dictated from the user, and the feedback of the motor is being taken, and those two are being compared, and the control action is being taken to fire the or trigger the power electronic switches present in the power processing unit. The power source in turn may be an AC or a DC, and the motor can also be an AC motor or a DC motor. The loads are generally a machinery which is designed to accomplish a given task. It may be a fan, pump, robots, washing machines, machine tools, trains, and drills, or etc. Now let us see the classifications of electrical drives. Due to lack of technology, electrical drives historically were designed to provide crude power without considering the performance. Advances in industrial manufacturing lead to the need of more sophisticated drives, which stimulated the development of modern systems. In general, electrical drives may be classified into 3 categories. They are group drive, individual drive, and multi-motor drive. Group drive consists of a single motor which actuates several mechanisms or machines by means of one or more line shafts supported on bearings. It is also called as line shaft drive. The line shaft drive fitted with multi-stepped pulleys and belts that connect these pulleys and the shaft of the driven machines serve to vary their speed, as shown in the figure. Here I have a single motor. Which is driving many loads, n number of loads, which is having a single pulley, and these are the load pulleys. These are all the load pulleys. And here I have a line shaft, which is through a belt. It is connected between these two. Even after taking into account the cost of line shaft, pulley, belts and other installations, the group drive is most economical one, since the rating of the motor used may be comparatively less than the aggregate of ratings of individual motors required to drive each equipment, because all of them may not be working simultaneously. So even though this line shaft drive is the oldest form of a drive, it has an advantage that the machine rating required to drive all the end loads is comparatively less when compared with individual drive, because the aggregate value of ratings of individual motors required to drive each equipment will be definitely more when compared with the single drive. But these group drives are not used because of the following disadvantage. Any fault that occurs in the motor drive renders all the driving equipment ideal. Considerable power loss take place in energy transmitting mechanism. Flexibility of layout of different mechanism is lost. It is highly inflexible, since they have to be located as suit the layout of the line shaft. The use of line shaft, pulleys and belts make the drive untidy in appearance and less safe of operation. The level of noise produced at the working site is quite high because of the more number of pulleys present in the driving system. It is highly inefficient and it is very rarely used in the present days. Next type of the electrical drive system is the single motor single load drive systems, which is also called as individual drive. In case of individual drive, an electric motor is used for transmitting motion to various parts or mechanism belonging to a single equipment or single load. For example, such a drive in a lathe rotates a spindle, moves the feed, and also with the help of gears imparts motion to the lubricating and cooling pumps of the lathe. In many applications, the individual drive consists of a motor which is specially designed to form an integral part of the equipment. In the case of individual drive too, the energy is transmitted to different parts of the same mechanism by means of mechanical parts like gears, pulleys, etc. Hence, there occur more power loss. The disadvantage is removed in the case of the multiple motor drives. The next classification of electrical drive is the multi-motor drives. In multi-motor drives, separate motors are provided for actuating different parts of the driving mechanism. For example, in traveling cranes, there are 3 motors, one for hoisting, another for long travel motion, and the third is for cross travel motion. Paper mills, rolling mills, rotary printing mechanisms, machine shops, metalworking machines, etc. employ a large number of multiple motor drives. The use of multi-motor drives and individual drives has enabled introduction of automation in production process, which in turn has considerably increased the productivity of different industrial undertakings. Complete or partial automation helps to operate various mechanisms at optimum conditions and to increase the reliability and safety of operations. So, because of this multiple motor drives and individual motor drives, the lot of industries has become automated.